Hello, blessings to you guys. Welcome to our mathematics grade 12 revision class. My name is Mr. Tauseni. Today we are still carrying on with differential calculus, particularly the graphs of cubic functions. Now in this lesson we are discussing how to determine the equation of a tangent. How to determine the equation of a tangent. How to determine the equation of a tangent. Now, a tangent is a straight line that touches a curve at a specific point. I think we remember meeting this same name in paper 2 Euclidean geometry, the tangent to a circle. So basically a straight line that touches, that line is a tangent. So let's have a look at this graph here. This is the graph of f, and if we say a tangent, remembering that it is a straight line that touches a curve. Now it touches a curve at one particularly specified point. So a line may cross the graph somewhere else, but if the line touches the curve at a certain point, then that line is a tangent. It is a tangent only at that particular point where the line is touching the curve. So this line H is touching the graph of f at point A, which means H is a tangent at point A. My line G is touching the graph at point B. That means G is a tangent at point B. My line here L is touching the graph at C, so L is a tangent at point C, and K is touching at D, so K is a tangent at point D. Important for us, the concept which is tested mostly in this section is that the gradient of the tangent equals the gradient of the curve at the point where they meet. The gradient of the tangent, so the gradient of the straight line and the gradient of the curve, they are equal at the point where they touch. That is the concept, the main concept that we are going to be dealing with in this particular section. So now let's have a look at one example quickly. The graph of f of x is equal to negative x cubed plus 1.5x squared plus 6x. The graph is shown below. Determine the equation of the tangent to the curve at x is equal to 1. Now, to determine the equation of a tangent, we need two pieces of information. The first one, we need the coordinates of one point that is on the tangent. The coordinates of one point that is on the tangent. And most of the time, we use the coordinates of the point where the tangent is touching the graph. Then the second one, the second piece of information that we need to know the gradient of the tangent. What is the gradient of this tangent? We need that information. Once we get these two pieces of information, then we are able to determine the equation of our tangent. Now, the next part will be, how do we determine these two? First of all, let's start with the gradient. The gradient of the tangent is equal to the gradient of the curve at the point where the two meet. So to determine the gradient of the tangent, remember from the previous lessons, we discussed that the gradient is the derivative. So to determine the gradient of the tangent, we use the derivative of the equation given. So we differentiate that equation. After differentiating it, we then find the specific gradient that we need by substituting x with the x coordinate at which the tangent is touching the curve. So let's have a look at this one. We differentiate this equation. f of x is equal to minus x cubed plus 1 comma 5 x squared plus 6x. After differentiating, we get minus 3x squared plus 3x plus 6. This is the gradient expression. Now, our tangent is touching the curve at x is equal to 1. So we need the gradient at x is equal to 1. That means in the derivative, we substitute x with 1, the point at which the tangent is touching the curve. So substituting x with 1 in this expression, we get 6. It means the gradient is equal to 6. The second piece of information that we need is what are the coordinates of the point where the tangent is touching the curve. It is touching at x equals 1. So we substitute x with 1 in the equation of f, and that will give us the y coordinate where the tangent is touching the curve. So replacing x with 1 in this equation gives us y is equal to 6.5. What it means now is that the tangent touches the graph at 1 and 6.5. With that information, we can determine the equation of the tangent. Y is equal to mx plus c is one of the methods we can use. Y is equal to mx plus c is the general form of a linear function because our tangent is a linear graph. In place of y and m and x, we are going to use m as the gradient that we just calculated, which is equal to 6 here. Then to find the value of c, we use the coordinates of the point where the tangent is touching the curve. X is equal to 1 when y is equal to 6.5. So substituting those numbers in the equation helps us calculate the value of c. Once we determine the value of c, we can make a conclusion now and say, therefore, y is equal to 6x plus 0.5. That is the equation of the tangent. So once again, like any other mathematics question, if you are working with maths, concentrate on making sure that you have a good understanding of the method that is being applicable. I do have some learners who say, say when I'm in class, I understand, but the moment I'm alone, I don't understand. It means you were not concentrating on the ideas that were being taught in class, because the ideas do not change. We can change the numbers and the way of asking, but the idea behind do not change. In this particular case, the most important ideas here are that the gradient of the tangent and the gradient of the curve, they are equal at the point where they meet. And also remembering that the derivative is the gradient. The derivative is the gradient. At any x value, we simply substitute that x value into the derivative to get the required gradient. All right, go to one more question here that is coming from November 2017 past examination paper. Now the question reads, given f of x is equal to negative ax squared plus bx plus 6, the gradient of the tangent to the graph of f at the point minus 1/7 over 2 is 3. Show that a is 1 over 2 and b is equal to 2 for 5 marks. This is coming from November 2017 final grade 12 examination. Now, from the previous example that I just discussed with you, we emphasized that the gradient is the derivative. And at the point of contact, the gradient of the tangent and the gradient of the curve are equal. Now look at how they've asked the question in this time. They are not asking us to find the equation of the tangent, but they've told us that the gradient of the tangent is equal to 3 at minus 1 and 7 over 2. Now, to answer a question like this using the idea that the gradient is the derivative, it means we need to differentiate this function. And take note, this is not a cubic function, this is a parabola, but the idea is exactly the same. So we differentiate our expression. After differentiating, in the derivative is equal to the given gradient because the derivative is the gradient. So that means minus 2ax plus b will equal to 3. Then in that equation, x is equal to negative 1. So at x is equal to negative 1, gradient is equal to 3. That means our derivative is equal to 3 when x is equal to negative 1. When we simplify that, it gives us one equation in terms of A and B. Then secondly, if you go back to the previous example we discussed, we said that uh, if you are given the coordinates of any point which is on the graph, those coordinates, they satisfy the equation of that graph. So that means when x is equal to negative 1, y is equal to 7 over 2. In the equation given, we substitute y, which is f of x, with 7 over 2. Then we substitute x with negative 1. Once we do that, we simplify that equation, we will get another equation that is expressed in terms of A and B. I think by now you can see where this is going. This is simultaneous linear equations. So equation 1 and equation 2, we can solve them simultaneously to determine the values of A and B. Then our question is answered. That is the idea of a tangent. So basically we have to remember that the gradient, each time you differentiate, when you are differentiating, you are determining the rate of change, you are determining the slope, you are determining the gradient. And with the cubic functions or any graph for that matter, the gradient of the curve and the gradient of the tangent, they are equal at the point where the two meet. That is vital for us, and also remembering how to determine the equation of a linear function, which is a tangent to a curve. All right, guys, thank you very much. I think that's all for now. How to determine the equation of a tangent to a curve. You need the one coordinate, particularly find the coordinate where the coordinates of the point where the tangent is touching the curve, and then find the gradient. The gradient is found by differentiating the given equation. Then you substitute x with the x coordinate at which the tangent is touching the curve. Then you can find your equation using y is equal to mx plus c. So please go through this video again, repeat it and repeat it. If you need anything more, you need more information, you are very much welcome to contact me using the number shown. Please remember to like and share. We will do as much as we can to support you. Remember, Wits is calling, UP is calling, and Cape Town University and so forth. They are calling your name. You can't fail to go to UP or Wits because there was differential calculus. Come on, let's be serious with life. Blessings to you all.